Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
As Kenji had mentioned yesterday, we actually had a bunch of external folks, folks from academia as well as scientists, and I think we had I'd say about 50 people here. Mm-hmm. Yeah, so we had a pretty good full house, and so far the feedback's been positive. We were just counting some numbers and seeing who might be utilizing Azure ML after they had seen it, and I think out of 14 recipients, maybe about 11 of them. So it's good. A lot of those folks didn't know Azure, so I had to kind of scan through that as well. So a bit of a learning curve. As Kenji mentioned, I think my relationship with this lab, I actually had worked in MSR, but I was working over in Redmond, and I worked on a number of engagements with Lucas and Drew on some of the environmental tool sets. So what attracted me to kind of come back and being moved into the Azure ML, and attracted me to move back to MSR for this engagement was really to kind of start working with some of you in either learning about how you do machine learning, learning how we can kind of incorporate some of those best practices back into Azure ML, as well as hopefully you folks get a good taste of Azure ML and say, hey, let me give it a whirl and try for the work that I do here. So we typically, the way that we have been doing this is that we did launch a workshop, a 2-day workshop back in June. It was the first workshop before I joined the team, and it was given to both internal and a few external folks to get feedback on the workshop. It was then replicated in pre-TechFest, I think it was, to an internal audience. So the idea is that the team wants to kind of roll out this workshop, kind of like a workshop in a box, and now start distributing it to the various geos. So that the geos, the sales and technical people within those geolocations can now start educating folks on Azure ML and machine learning. So we've learned a lot just kind of by going through it yesterday. My point is that feedback from you folks on the way that we present the day's course is great, because we can roll that back into the course, make some adjustments before we roll it out to the field. So your input would be fantastic. So we typically start and I should just mention too, Kenji sent out 3 invites. So there's the invite for this hour session, which is more of an intro. If you want to stay throughout the whole day, the middle section, which is the meat of it, is actually with your laptops going through the entire course. And then at the end there's an hour session that Kenji sent a separate invite for, where it's just kind of an open dialogue and conversation amongst all of us at Microsoft about input into the product, what you saw, as well as future directions of the product. Sound good? So feel free to stay all day or just stay for this session and come back later. So the first deck that we typically do is we do an introduction to Azure Machine Learning, and what we're trying to do there is position to our external audience how we take a look and view machine learning, as well as it kind of presets how we actually design the product and the workflows that the product actually has been designed for. So, and I'm going to go ahead and skip that. So really kind of, this kind of says, machine learning, computer systems that improve with experience. So let's talk a little bit about what we're seeing and what we're hearing, from the community, and what we're thinking about and how we make machine learning accessible to a wide range of audience. And that's really what we're trying to do here at Microsoft with this product. Typically what we do is we describe a couple of scenarios. I actually cut out a few, some of them that's well known here, for example, the Xbox learning stuff. But we talk a little bit about machine learning in the context of the United States Postal Service, where last year the U.S. Postal Service processed 150 billion pieces of mail, far too much for a human to sort. But as recently as 1997, only 10% of the hand addressed mail was sorted automatically. And the question is really why? Why was that the case? And the real case is that because it's a really tough problem. Just imagine that when you basically pick up a letter that's been handwritten, the address and all the different ways in which people write addresses, and you take into consideration all the nuances of their script or their print, and then trying to kind of evaluate that successfully is very, very hard. But this is really such a good problem for machine learning. We could teach the machine to read the mail, and how can the machine learn and get better over time? And that's what all machine learning is all about. So by providing feedback, in both in terms of humans training the machine learning models and the machine learning from the patterns in the data over time, we've actually been able to get better and better and accurately train machines to basically read handwriting. So this is where the learning part of machine learning comes in. Data scientists created a model based on all the data that they had and how people can write addresses. They train the model as more data comes in, correcting attempts at reading handwriting when they're off. And then finally, until the model has enough of the history to draw from that, we can accurately predict and read handwriting. So today, with the help of machine learning, over 98% of all email is successfully processed by machines today. A really good canonical application, this I would say is the first probably killer commercial application on big data, was web search. And with machine learning, we can use all the billions of queries and associated clicks that we collect each month as training data for the machine learning system. So I spent a few years, for example, in Bing Search, and as you all know, we collect volumes and volumes of data every day, 24/7. And we process that data in very different ways. One example is, utilizing machine learning and processing the data to determine which links are most likely to get clicked, right? That's very canonical for this kind of scenario. Also, determining, for example, which items are misspelled and offering the correct spelling and kind of making that guess and that recommendation. Another slice of machine learning is also what language did the person enter in, and how do I interpret that to kind of bring my result set. Also, what is the intent of the user? So can I look ahead and predict basically what they may be wanting to do with the query string that they had entered within the search string? Are any of these pages malicious? So there's a whole bunch of pre-processing and machine learning that's even done before we actually go ahead and start displaying result sets to the user. We don't want to communicate, for example, pages and page links that might be malicious, obviously. Also, what's the probability of a click on each ad, right? So now this directly affects the amount of money potentially that we can make as a business, right? So we want to make sure that we're actually ranking those things. We understand what the prediction is and actually rank them accordingly. And also which ads to show, and also in what order. Again, that affects basically the probability of a click of an ad as well as revenue. And then lastly, what pages should be indexed and what pricing optimization to revenue. So basically, for every click and for every search that someone does through Bing, we have a lot of different hard problems to solve. And you wouldn't think that all this processing is going on behind this single page, but when you take a look at the entire Bing stack, it's made up of a stack probably about 20 different operations that are very deep, from not only doing some machine learning, but also for organizing what material we actually surface up to the end user when somebody types in a query. So machine learning enables nearly every value proposition in web search. Lastly, and something maybe I can bring a little bit more closer to home about talking about the service, is system logs. So these are system logs from Exchange and Office 365 in our Dublin data center. And when the team wanted to build a data center monitoring utility, They took all of the rules and all of the triggers that currently exist in the System Center that they were using for managing this. It turned out that the system was getting so many false positives and false alerts and missing the really important alerts, they simply shut the system off. It was just completely unusable. So a new team kind of went in and they focused on capturing time series coming from every sensor on the rack. So everything from network cards to the heat of the system, all the way through to the response time from the service itself. And then whenever a failure occurred, they typically asked the technician to kind of classify the failure. So really what was happening is they were building a training set for use. Oops. Oh, sorry. I got a pop-up here that new software was installed. The team was able to take that large corpus of time series data and the classification of the error and deploy basically a machine learning service that now today monitors all the feeds of the services. And with that, as well as the hardware, and it predicts errors kind of in advance through a dashboard, and in instances accurately classifies the problem, saving the operation time and diagnostics. So in Bing, if you've ever got a chance to go ahead and visit some of the sites where we manage a lot of the hardware, we basically have technicians who, throughout every day, 7 days a week, are going around and replacing pieces and cards. And we're now down to a point where we can actually go ahead and start predicting where potential failures might be based on temperature, also based on things like temperature, utilization from a hardware perspective, and start replacing and start getting ahead of that. So it's super important to kind of keep the business up and live and making sure that our customers actually have a great experience when interacting with things like Bing or Office 365. So hundreds and hundreds of machines, hundreds of metrics and signals per machine. And the really quick question is, which signals correlate with the real cause of the problem? And then how can we extract effective repair actions? As well as, and all this stuff basically affects revenue, it affects our SLAs to customers, and so on and so forth. There's obviously lots of other uses of machine learning at Microsoft. A lot of the work that we actually do here in the Cambridge lab related to Xbox Connect, commerce fraud, anomaly detection in SQL Azure, churn prediction in Halo, and add keyword bid prediction. Those are just a few of the examples. And the thing to note, too, is that Azure ML, a lot of the algorithms that ship with Azure ML actually came from Microsoft. Quite a few of them are in use today within Bing, for example, or within Xbox. And what we've been able to do with a lot of the help, for example, from John Bronskill's team, is actually go ahead and packaging them up, testing them, and making them widely available to our customers. So it's really, really kind of cool to see how a lot of the learnings that we've done here within Microsoft are now being able to move out into the public. So for us, we see the promise of machine learning. It allows us to solve really hard problems better. We can definitely extract more value from big data. In fact, those of you who are sitting on big data troves, you can start to ask yourself, what can we extract by applying machine learning to detect patterns, and how we can use that data to kind of get extra value. And then lastly, we kind of see it as an opportunity to drive a shift in business analytics as well. So in particular, what we're going to do is focus today on predictive models. And predictive models really address the likelihood of something happening in the future. And when you take a look at the breadth of different applications that you can apply predictive analytics, it's quite broad. Everywhere from churn analysis to managing your customers, social network, analytics for sentiment, is it trending positive or is it negative? Can we build a recommendation service to recommend products and not just make it available to big companies, but also small companies as well? There's a breadth of applications where you can really apply machine learning. And what we're trying to do with Azure is ML, and one of the key components of Azure ML is where once you've built your model and you've trained it and you're really excited and you know basically it's working well, it's very easy to go ahead and publish, for example, a service directly from it, expose a REST API, and make that either callable by other applications within your ecosystem and or potentially put it on a marketplace and sell it. So that's a little bit about how the Azure ML is starting to kind of position a little bit of the product, the team rather. The team's looking at this from the perspective of making machine learning available to the masses, as well as providing opportunities for people who are sitting on data, who have some unique models, to kind of expose them externally as well. So, listening to our customers, so some of the things that we've heard as a team is that access to quality machine learning algorithms is really hard. Typically, you may, if you're a data scientist or a statistician, you may be scouring the web. You may be speaking with people who also do very similar things. You get an idea and notion about, hey, here's a good algorithm for this. You get it over here. Here's a good algorithm for that. You get it over there. Or you're also kind of building your own, or you're purchasing very big packages for a lot of money to try to find that good quality machine learning algorithms to support your business. So it's hard. The other thing, too, is that when you think about the whole end-to-end process of machine learning actually deploying, for example, models into the world for use, you need to learn a lot of different tools to complete the end-to-end solution. So from data acquisition, cleaning and prep, to machine learning and experimentation, and then finally it's putting it to deployment. We've done some analysis, some studies. We've reviewed some studies, and we've learned that less than 30% of all models actually go into production, which is a bit of a shame. It means that people are building these things and they're just not being utilized very well. And part of that reason is because of the dichotomy in the tool set and the different skills that people have. So, for example, from a data scientist or statistician, you're probably going ahead and utilizing the tools for, the data acquisition, the cleaning, and the prep, and the machine learning experimentation. But yet, it's a completely different tool set that the person who needs to deploy it is utilizing. They're thinking about, how do I secure it? How do I kind of deploy it? How do I go ahead and scale it out? And those are things, for example, that the statistician is not thinking about. Pretty much when they're done, they throw it over the wall, and expect somebody to go ahead and put it in production. So there's a cost to put it into production too. That's additional dev resources potentially as well. So it's hard, and you can kind of, when you think about it, that problem, you can kind of understand why probably less than 30% do actually get deployed. So, we believe that data science must get simpler, and that's what we're trying to do here with Azure ML Service. So what we've built so far is basically, it's a fully managed cloud service. It's all browser-based. There's no tools or applications or code to install on your laptop or your desktop. It's fully composable, so modules to support end-to-end data science workflow. And we'll talk a little bit about the workflow in a couple of minutes, because it's very important, because it's kind of like the foundation of how we've built the product, but how we believe that our customers approach doing data science. We have the best-in-class machine learning algorithms, the same that support Xbox and Bing or in ML Studio, as I mentioned earlier. We also have support for R, so we do recognize that many customers today utilize R. And there's more languages coming fairly quickly. The other important thing, too, is that we want to promote collaboration, collaborative data science. And by having it as a managed cloud service, it gives us the opportunity to provide to our customers a way in which they can kind of, for example, collaborate on experiments, collaborate on models, collaborate on data. So, and we'll show this in a few minutes, but the ability to kind of give permissions for somebody to go ahead across the globe to work on your experiment, and just kind of make that very easy to do without having to, again, ship files on a thumb drive or a share somewhere or a model and get out of sync about what version's the right version. And then the other thing too, as I mentioned earlier, is we want to quickly deploy models as web services for both REST and response and batch scoring. So this is also a very popular kind of feature. When I speak to a lot of folks who are in this field, that excites people a lot. And if you do stick throughout the day and you do go through the workshop, one of the things that we'll do is we'll show you how to deploy, for example, a classification model. The other thing too that we want to do is rapid experimentation to create a better model. So we do know that data science is often about which ML algorithm is best, and there's really no way to kind of tell which one's the best heuristics out of the box. So you have to try different ML algorithms. So the system's been built so you can experiment quickly and take a look at the results, and if you need to, back out or try something very quickly, something different very quickly. We have the immutable library of models, search, discover, and reuse, and supporting the rapid try of range of features, algorithms, and modeling strategies, and then deploy it. So I want to kind of transition real quick to how we think about the workflow, for example, of a data scientist and doing data science. Many people kind of look at this and you kind of think about, well, geez, you just clean the data and then you create the model and then you're kind of done. And we wish it was really that simple, but it's really much more complex than that. When you're doing data science, really the process model that we think about is that you first sit down, you define basically the objective, and quantify it with some kind of metric, and potentially with some constraints if you have them. And this really requires some amount of domain knowledge, right? And that domain knowledge you may have, or it's domain knowledge that you need to kind of seek out as well. And that takes a little bit of time, but getting that right is super important. Next, you want to collect and understand the data and deal with a lot of the vagaries and the biases in the data. And sometimes you have to acquire it. And when you acquire the data, sometimes it has missing data. There's outliers due to errors, and it introduces potentially some more sophisticated biases. After that, then you start thinking about the problem and frame it in terms of the machine learning, and then you have some classification. You think about regression, ranking, clustering, and some combination of domain knowledge, and then the machine learning knowledge is starting to become useful. And then you start transforming the raw data into a modeling data set. So you actually haven't even done any data modeling yet, right? You have to think about the problem. You need to kind of collect the data. You need to look at the data, work with the data to get into a form that you might want to be able to go ahead and plug into a model. So once you have that, you start taking a look at it and you start training it, testing and evaluating, taking care to control bias by vigilantly against target leaks. And this is kind of like the machine learning heavy step. So training and splitting, doing some feature selection, some model training, scoring and evaluation. And the thing is that this process isn't just a one-time thing, right? So most often what you're doing is you're iterating steps 2 through 5 until the test metrics are satisfactory. And then lastly, what you're doing then is you're kind of deploying the trained model, ensuring that the model is reproduced faithfully in an environment. You're monitoring the data distributions, both model inputs and outputs, and you're retraining as necessary. So it's basically, it's kind of like this journey that you kind of go through. And what we're trying to do when we think about Azure ML and the product is that we're trying to kind of support that entire journey through one single tool that doesn't require any product to be installed on your desktop or laptop. So, so today's agenda, if you do choose to kind of stay, what we're going to do is we're going to actually follow that workflow, and we're going to go ahead and touch every part of the product to basically talk about how we support data ingress and egress, data visualization, transformations, and doing some feature selection. We'll have a brief talk on predictive models, followed by we'll build the classification model, and then we'll go ahead and operationalize it. So we'll actually turn it into a REST API with request and response. So let me just go ahead and just give a quick tour of Azure ML. Quick question, how many of you have even looked at the product or using it? No? Okay, there's about more than half. Good. So some of this, so typically what we do is, let's go through here. Let me just switch here. Grab this real quick. Better. There we go. Okay, so let me go to the Azure website. Okay, and go into the portal and log in. So Azure ML is currently in preview. The team is working to putting it into final production or GA. Best guess is it's probably going to be early next year. We're actually making a number of changes, including user experience. We're also getting a lot of feedback from customers, so incorporating that into the product as well. But what we would do basically is there is a machine learning service down here, and click on that and create a new machine learning. Do a quick create. Give it a workspace name. The workspace owner would be me. The owner is utilized basically for managing permissions. The location right now is South Central US. That's only because it's in preview, so it's just right now limited to a single data set. As soon as a single location. As soon as it goes into production, I'm sure it would be available in all of our other geolocations. Can you use your org ID? Yeah. What's your org ID? It needs to be it needs to be a live ID. Okay. Yes. And then you want to provide it with a storage account. If you don't have one already, you can create a storage account. The storage accounts are utilized in two ways. And really what that is it's blob storage. It's utilized, number one, for just managing a lot of the projects and things like that. But it's also utilized for storing any data that you might bring into the system as well. So as a result of like data ingress or results. So I'm going to go ahead and create what's called an Azure ML workspace. And as you can see here, I actually have several workspaces. So there's the one that I had just created. Let's go into that real quick and sign into the studio. So ML Studio is basically the environment that you primarily work within when you're importing and exporting data, when you're doing data visualization and transformations, as well as experiments and so on and so forth. At the home page, we have your standard, basically, access to help. And there's quite a few videos that are available, and those videos are growing every day. Also, if you go to the external Azure website and navigate to Azure ML, there's a whole bunch of experiments there as well. On the Experiments tab, this basically would show you what experiments that you have completed. If you click on, for example, samples, you'll see a list of samples that come out of the box. So, direct marketing, a movie recommender. There's a whole bunch of different kinds of samples to kind of get you started. Finally, web services. If you were deploying, and we're going to deploy, for example, a model out as a web service later today, you'll be able to see a reference to that and manage that through this page. And then finally, settings, which is just basic settings like your workspace name, description, authorization, tokens, and users. If I click over here, as I mentioned, one of the things that we're really striving at is to make it a very collaborative experience, so that people can collaborate on a particular workspace or an experiment. It's really workspace. Think of that as kind of a container. That's what we had just created. So, and it contains both data as well as experiments as well as management types of things. So here, as an example, I'm associated with let's see, so 5 workspaces. So within those workspaces, there could be many experiments as well as large collections of data. Now, I just happen to create those, but if I wanted to, for example, invite one of you to my workspace and collaborate, I could do that with your live ID. So that's where some of the authorization tokens and the users kind of come to play. And it's very easy once I'm logged in. As me, not only do I see the workspaces, but I can also go ahead and click on one and flip to that one. So if I'm working on with multiple colleagues, I can go ahead and switch back and forth to different workspaces. Let's see. Let's just go ahead and click on one of these samples. And so this is kind of what a sample might look like for training, testing, evaluating a binary classification for an adult data set. And actually, we go ahead and do this experiment. We actually go ahead and do this experiment throughout the day. Let me bring it in real quick.
I've got a couple of questions.
Yeah.
So I'm quite familiar with working in the Azure portal. The menu you just selected there, I would normally go to change permissions for my subscription, which is very similar to what you're describing, giving people access to my subscription, my web services. But you're talking about machine learning workspaces here.
Yeah. Yeah.
So is that in the background modifying my subscription permissions as well?
No, it's not. So the way to think about it, there's actually 2 tabs up there, right? Up here, if you look. One is basically what you would probably see if you were utilizing Azure, correct? So on the left-hand side, you have all of the services. ML Studio, think of that as kind of like an app in the cloud. Right. So really what you're doing when you're basically setting up permissions and in that workspace or the Azure ML Studio, it's really for that application, and it's really only for that container, which is basically the Azure ML workspace that you're working within. Right. So they're separate from anything that you might do, for example, through your Azure portal that you have today. Right. So really, what I'm saying is that I've created an Azure ML application workspace. When I clicked on Sign On to ML Studio, that's my application. So think of that as almost like Visual Studio. It's where I do everything. And what I'm really doing is I'm granting people access to these workspaces or these containers that are managed by Azure ML. Okay. So that's let me see if I can just pull up a quick example here. Yeah. Okay. Yep. Okay. Okay. And so throughout the day, what we'll do is we'll go ahead and create some of these experiments and do some data transformations and stuff like that. Any questions so far? Take a look at the slide deck here. Yeah, so that's my last slide. And that's at least for the first part, the introduction. Folks want to keep going on? Yeah? Yeah? Okay. Well, if you'd like to leave, feel free to. Else, we're going to kind of jump into the actual workshop part.